Right, so looks good. Everybody has a project? Good. Any quick questions about the project work? So what we will do today, we will talk a little bit about Go. I have one extra topic about Go, and then we will talk about AWS, about all the services and the infrastructure that AWS offers. Unfortunately, you sort of need to put your credit card if you want to try the free tier. You can do that. I think they have some deal with GitHub as well. So if you get the pack, the GitHub pack from GitHub, you can get some credits for your AWS usage. It's one of the biggest cloud providers out there, and it has the most comprehensive offering. Like there are many different ones, but we choose to discuss this one because it's kind of the most comprehensive. The other ones are very similar. But first, a short detour into Go. So let's do a small example. So do I have some? Let's go hello world. So let's imagine that we have a situation where we have a function which returns another function, and then we will call that function. Okay. So we kind of discussed that before. We had yeah, it's a very complicated hello world. I actually have a package that was kind of an explaining. It was explaining the commands. So we kind of are calling hello world from here, right? So let's do a slightly different thing. So I will have a hello world and I will have a function. Yes. Yeah. Which does something. So yeah, let's call it counter, okay? And the counter takes some parameter, does something, and then returns a value which we don't use, okay? So then I can call it 2 times, right? So now I go and implement it. So oops. So I have a function counter that takes takes integer, returns an integer, and it does something with a, do something with a, and then what we want is we want this function to return us how many times it was called. Clear? So I have a module and I have a counter function which does something, and then I want it to return how many times it was called. How can I do that? So I'm calling it in here I'm calling it twice. So here it should say so if C is how many times counter was called, C should be 1 here. And then if I check it here, then it should be 2, right? C equals 2. And I will print it. So yeah, we can print C, so the compiler doesn't complain. So how can I count how many times I did it? Yeah? Static, right? What is static?
Explain?
Yep. Yeah, so unfortunately, Go kind of doesn't like that, right? Is there static in Go? Yeah, so there is no, like, the Stack Overflow answer was use closures. Okay, so we can't use static. And that's my point here, that we want to kind of learn a pattern of how to do that without static. If we had a static, like in some programming languages, I could say, static counter equals 0. And then every time I am called, I would say counter plus plus, and then return counter, right? So I will kind of have pattern like this, where this variable is one place in memory, and it's, if no matter who calls this function, there is only one version of the of this variable, right? And it kind of continuously is incremented, and depending how many times I call this, this will be growing, right? So that's exactly how I would do it in C++ or in C or in Rust or in some languages or in Java, some languages which have a concept of a static. If I don't have a concept of a static, how can I do that? Yeah, any other suggestions that are easy to do in Go? What if I have a global variable outside here? What if I say, well, let's have a variable counter, which is an int? Would that work? Sure. So I say counter plus plus, return counter, that would work, right? What's wrong with this one? Huh? It's a global variable, right? Like anybody has access to it. It's a little bit icky because, you know, my hello world can say, oh, counter plus plus, right? And it messed up already, you know, what's happening. I have no control who touches that variable, right? So it will work. It is one of the pattern that you can use, but it kind of smells. It's not nice. So we want something that would kind of work like this, but without exposing the counter to the outside world, right? So how can we do that? Well, so if you kind of dealing with functions, one possible way is you kind of enclose it with a closure, which means I have a function which takes an integer and returns an integer, and it has this variable and returns a function which does that, right? So yeah, I should have a comment because it's an exported function. Would that work? It would work. The difference is that I need to get this function first, right? So here I need to say I have my, I don't need capital, counter, which is hello world John counter, and then I do that. Okay, so I have a function now, which was the original counter function. And this function can count how many times it was called. And every time I call this function with 3 and 4, the return will be how many times that function was called. Correct? And I achieve that by enclosing an additional variable, which is single for all the invocations of that function, right? So every time I call this function, I modify that single version of the counter. So it's sort of like a static in the context of this function, which I have here. So in the context of this function, I have as if I had the static variable, which is only one place in memory, which all the calls are kind of manipulating. And nobody else can touch that static variable, right? It's enclosed in the other function, and nobody has access to it. The only function which has access to it is the function here. So I have nice encapsulation. I can maintain a state across multiple invocations of a function, but nobody touches me this variable. It's like untouchable, like nobody has access to it. Right? So it is kind of like a global variable, but it's not global. It's local to a scope of the function. And this thing here is a closure which uses part of the environment in which it was defined to maintain a state. Does it make sense? So it's one of those patterns where you can use when you need a static variable in Go. So every time you think, oh yeah, it would be nice to have a static, or a global variable, you have to think, do I really need a global variable or a static? Can I kind of have a closure instead, right? The nice thing about this is that you can parameterize it, and you can take this and put it as a parameter to the generator and pass it somewhere else, right? So you can pass it to a logger, which will be checking how many times something was called, and you can kind of decouple that, right? And you still don't have a global variable, but you're in control of who you gave the pointer or kind of the counter to handle the situation. So, yep.
Will that work without using a pointer? You generate, you create the counter variable, say, in the main function. Then you pass that as a variable.
But then you would pass it by value. Yeah. Exactly. So you would have to use pointer, right? You really need one single point in memory for this. And this offers one single point in memory, right? So that's a short detour about kind of using static, and also about using stack and heap, right? So when I'm allocating something, I'm kind of allocating it on the heap, but when I'm declaring a variable inside the body of the function, I actually have this place on the stack, and the compiler can optimize it, and it can actually work faster, right? So this generally works kind of nice because it's within the frame of the function which we are using. So access to it is usually more streamlined than when you're using kind of a main memory and using heap, because you can kind of keep a value in the register instead of accessing the memory. But yeah, that's not too important. The important part is this closure concept. So closures are like this closure here doesn't have a name, so it's an anonymous function, right? I'm generating a function, but this function here doesn't have a name. I didn't give it any name, right? I gave it a name here, here, so I called it counter because I assign it to a variable, and then I can call it. But this function basically generates me a closure, and the closure has part of the environment in which it was defined, and then I can use it, and this function has access to that environment. So sometimes it's useful to do that if you have some sort of context and you don't want to pass it around, if you want just one instance. If you don't need static, and if multiple values are okay, then usually you do that by passing parameters, by contextual, making the context kind of a passable reference. So that's one pattern. The second one is for testing. So we kind of force you to write tests, and the purpose of it is not to have a great test coverage or anything. The purpose is that you have to structure your code in such a way that you can write the tests, right? And it's different. So normally when you're writing code, you kind of writing it as a single monolithic blob, which is really hard to decompose when you want to test some internal things. And then if you need to write tests, then you realize that you cannot call the main thing and then test everything, because you cannot isolate the little parts that you want to test, right? So for example, if I have I give you another very quick example. So let's have a function here. So let's have a function which processes some data, right? So process data, and it takes let's say it takes whatever, like it takes an integer as well, and then what it does, it kind of accesses the database and makes some calculations based on the database, right? So I have int, and then this function kind of does the processing, right? And uses database, and then you basically calculate the result, right? And what can happen is the database may fail, or you may be using some external service or whatever, right? And then so you have kind of a path. So one path is it's true, it worked. So you return a value, and then the other path is that something went wrong. So your database or your REST service didn't work or something, right? And then you need to return an error. So we need to add that you may have an error, and then path is true, you return 1, and then path is false, something went wrong, and then what you would do, you would return you will return some default value, 0, and some error, right? So you'll have a non-nil error, right? And you wrote this like this. So you have your handler, you have some processing, and you're doing it, right? Is it typical kind of a data processing function that you would write? Sure, you would do that. So you handle the error by returning the error if something went wrong, and then if everything is fine, you just return the result, right? What's wrong with it? Well, what's wrong with it is that if you go and now you need to write a test, right? So you're testing it. So you're calling. So you have your result equals how we call it process data, and we're passing some parameter, and then what it can return is it can return result and an error, right? In your test, right? So in your test, you're doing this. How can you force it to fail? Or how can you force it to succeed? How can you test that it can fail or it can succeed? That it returns a proper error when this data processing fails, like when there is no database. How can you test this? You can't, right? Because this will always return true. Like if you instantiate your system and you have your database, and that this function will always return true. It will never return you an error. So how can you test the error situation? Exactly. So you can't write code like this for tests. You can write code like this, which is a monolithic single blob for a normal application, and it will work, it will be fine. But when you now have to test this, you have to test the path which is true and test the path which is false. Suddenly you have no ability to inject a database which is closed, for example, and then it should fail because it cannot access the database. Or you should inject some REST API which returns an error, right? So when you call the normal REST, it will always return you true because your code works, right? So testing the true branch is fine, but testing the false branch is not. So normally what you do for testing is you kind of inject something. So let's say we're doing it with database, right? So then you have some sort of a database handler which you instantiate as an interface or as a struct or as some sort of data type that you can mock, right? So you can say, okay, I have the handler to my database, and then I'm actually calling the process thing, right? So now in your test, when you go to your test, it's easy because if you want to test the true branch, you pass the real database with the instances and everything that is there, or a mock database which returns the result, which works, right? So you can test the one possible thing. And then you can do that again with prods data, and then you can pass a mock fail db, and then you can test the situation where the database responds like not available or the database is closed. Therefore, this method here will say, okay, I cannot read the database, therefore I have to do this path, right? So you can test the true path and the false path. So your way of structuring your API suddenly changes because you are more flexible. You're more kind of thinking of how to make your code testable, right? So that's why we're kind of forcing you to write tests, not necessarily that you actually have everything working, but that you think about the architecture and the structure of your code in such a way that it's testable. Does it make sense? Right, so those are kind of a simple things, like a simple change. Like you just inject what would you use. Like otherwise, if you don't inject it, normally you would open a database here. You would have the code kind of in your function. You somehow open the socket to the internet or whatever, to web server. You would have all this code here, right? But it's hard to test. So what you do is you isolate this opening of the database and everything to the outside method or function. Then you pass the reference, and then you do the logic. And suddenly your code becomes much more modular because you can manipulate how the database is instantiated, right? You can use a mock. If you're doing it everything here, you have no ability to change it. Like it's hard-coded here, and that's what it uses. It uses real internet and real database, right? So with this kind of parameterization, you are much more flexible what you do later. And it actually is a better way of coding because you can use different databases. If you put it here, there is no way of changing anything. But if you parameterize it like this, you are much more flexible. All right, questions about those two patterns? Great. So those are kind of a simple things to think when you're doing a project. And if you're writing tests and you feel it's hard, it means you probably need to reorganize your code. Your code should be easy to test, but if it isn't, then you probably should change some things. Also, if you're testing your code and you in Golang or IntelliJ or some other IDEs, you can actually see the test coverage. What it will show you, it will show you green all the lines of your code which has been tested, and red lines which hasn't been tested, right? So sometimes you see that, for example, the true branch is all tested and the false branch is not tested at all, right? And then you have to ask yourself, okay, why I never tested that part of code? And then you will see that, well, all the tests only test a particular branch or particular execution. So how can I test this non-tested thing? And then you have to be a little bit more creative, how you can force your test to touch the particular part of the code which normally is not touched, to get the test coverage better. All right, so let's move on to AWS. So what's Amazon? Yep.
Can we have a break at some point?
Yeah, we'll have break in 6 minutes. Yeah.
Amazon is a cloud service provider.
Service provider. It's not a bookstore. AWS, but Amazon.
Amazon is an umbrella for everything now.
Exactly. So if you go, come on. If you go to Amazon.com, oops. It's an online store. It started as a bookstore. It kind of sells stuff, all right? So how come from an online store they became a service provider? Yep.
Didn't they already have like system when they started providing that system that they made it for originally for their own purpose?
Yeah. So why they made it for their own purpose? Yeah.
They're selling stuff online and they have service side. That has actually proven to be false though. That was what they're doing, just using their leftover servers for that purpose.
Exactly. So why do they have leftover service? Why couldn't they build what they needed and then just use it? Yeah.
Overhead.
Huh?
Overhead. Christmas time, people are shopping more.
Exactly. So it's the usage is not uniform. It's not a straight line, right? During Christmas, you have a huge spike, and then in normal times, it's much lower. But you need to be able to handle the huge spike, because otherwise you're losing money. Like if people go and try to buy something and you cannot serve their requests, you're losing money. So you have to have a capacity which is here to handle the peak, but most of the time they not work at the peak. So most of the time they have a capacity which is much larger to what they need, and that creates a surplus, right? So they thought, okay, most of the year we have all those servers, all this infrastructure, which we don't need. Like we only need it really for Christmas, and the rest of the year we don't. So apart from creating those Black Fridays or whatever, right? So they decided, okay, we will rent it. We will kind of give out all this capacity that we have, so people can use it when we don't need it, and then we recover some of the money from it. And it turned out to be a very lucrative business, right? It turned out to be like much more lucrative than actually selling all the stuff. So then it grew, and other service providers jump on it. Where else do you have similar situation? Where else you have a similar situation where you have to deal with peak demand? What examples can you give me? Yeah.
The Norwegian IRS. They deliver once a year.
Yes.
Have a lot of traffic once a year.
That's right. Well, all countries, not just Norwegian. Like every country has a deadline for submitting your tax returns, and then the servers always go down, right? So how they handle it? Well, first of all they split the business customers from the private customers into two different dates. So then they make the commercial customers kind of spread a little bit more. So as a company, you can change your delivery date. As a normal person, you kind of are fixed, and then they do most for the normal people, so they kind of reduce the demand. Where else see the peak? Yeah.
Basically everything that's seasonal. Airlines before vacations.
Yeah.
You can also see people are usually not ordering after November, so then airlines will be kind of quiet for a while.
Exactly. Yeah.
Release dates for AAA titles games.
Yeah. That's kind of built on purpose, right? So they kind of create a hype on purpose to get this kind of a peak interest. Yeah.
When some very popular show comes out, for example, Game of Thrones,
Yeah.
would place copies at the ISP level.
Yeah.
So you would copy it there.
Exactly. So usually it's like popular shows, or for example Olympics or some soccer World Cup. Suddenly everybody wants to watch it in real time, and you need to have kind of a delivery network which deals with the demand. So you see that like in a lot of places. Telco was dealing with it for a long time, like with the telephone calls. So we know, for example, like after midnight of New Year's Eve, everybody sends SMSs and everybody wants to call everybody to wish them, Happy New Year, right? And then there is a huge demand on the telecom network to support this, and then most of the time it's not used that heavily, right? We had the situation in New Zealand where they had a city covered with the wireless coverage for like mobile phones, and then they built a stadion, right? And suddenly, 30,000 people are in the stadion and they want internet or they want to do something, and the network is not able to do that because the network was designed for 1,000 people, not for 30,000, right? In that one spot, right? So the cell towers and everything were not designed to handle the traffic which the stadium suddenly generates. So again, you need to balance that. And then maintaining this high capacity is kind of costly, right? So you have this big buffer where you need to maintain it because otherwise you're losing business, but maintaining it for most of the time is kind of pointless because you don't need it, right? So we have two concepts here. We have best effort, which means, well, if there is a demand exceeding the capacity, you will not be handled. Or we have a quality of service which guarantees certain connectivity or certain service, right? All right, so let's have a break, 10 minutes, and then we continue with the AWS.
Because we would have to actually mock up the microservice stuff, we figured
We talked a little bit about the history and why they do that. And then those are slides from last year. So some things don't change. So we have a number of services which they offer. And we will go kind of shortly through them. I just want to go and do a little bit of a comparison. So EC2 is the main kind of a computing facility for hiring CPUs and RAM, storage, load balancing, virtual networks, and Lambdas. We will talk about Lambdas a little bit more in detail shortly. But if I go to the AWS console and I open the offering on what AWS offers, you have a huge page of all sorts of different services which they do offer. And on the compute side, yes, EC2 is still like the core, the most important one, but we have some new ones here, which they did have last year, but they were not as prominent and not as important. What do you think are those? Any? So E always stands for elastic. So if I continue here, we have, elastic block store. So EBS allows you to store data on a kind of a block based file system, which is very typical to your hard drives. So anything that runs an operating system will require kind of a block storage because it needs something that looks like a normal file system, right? So this is the primary backend for OS or for database storage, because the database or operating systems, they require the storage to look certain way, and they expect certain properties. So that's EBS. But you can store things in different ways. And typically when you're managing your application, you don't care about the physical layer of how it is stored physically on the disk. What you care is the logical layer, like how you organize your stuff, right? So for example, when we were storing things in Firebase and using kind of a document-based abstraction, you don't care how it is physically laid out on a disk. For you, the unit was a document, a JSON, and then you were writing it and reading it. And how it physically is laid out, you don't care, right? So you can have a different ways of storing stuff. Imagine you want to store images, right? Image is a binary blob of bytes, and then you are storing and reading images. Then again, you don't care how they are laid out physically on the file system. You just want to know how can you address, read and write a binary blob, right? And typical use case like, okay, JSON blob, binary blob, a document blob, they are a very common pattern. So in the language of cloud services, they use a term bucket, right? So you have a certain bucket of things that you can store in a bucket and read from a bucket. And then it's up to you what you want to store and read from it. You don't want to know, and you don't need to know how it physically is stored actually in the file system. So for those bucket things, Amazon has something called S3, which is a simple storage services. And again, the way things are physically stored matters for them how much it costs, right? So for example, you can physically store something in RAM, right? It will be really fast to access, really fast to read and write, but it's kind of costly because you need a lot of RAM to store everything in RAM, right? But I/O operations are extremely fast. On the other end of spectrum, you can write something to a tape. You remember those kind of magnetic tapes which were used in ancient films? You can store something there, right? The read and write are very slow, but you can store terabytes and terabytes of data there, and for years, right? So you have this kind of a glacier storage where you want something just to write, for example, a log file or a copy of something just for records. You're never gonna read it. You're only gonna use it if in terms of like a backup recovery or something. Like you are very unlikely to, after a write, to ever read from it, but you still want to keep it, right, as an archive. Then you can use this kind of glacier storage. So depending on your usage, you need to pick what sort of storage you want and which storage is kind of appropriate for you, because you will be charged accordingly. This one is very cheap. This data archiving thing is extremely cheap, but it's slow. Whereas this one is very fast, but it's expensive. And then you have some things in between, right? All right, so EC2, it's effectively a computer. It's a CPU and RAM that you're renting. All the service offerings boil down to some sort of a computational units which need to fuel it. And the instances can be optimized for computations. So then the CPU is very powerful. They can be optimized for RAM access, for I/O with RAM. So they may have a large RAM storage, or they can be optimized for I/O. So for the disk reads and writes. So again, depending what you want this VM for, you can get one of those kind of optimized ones. They also offer the ones which are optimized for scientific computations with GPU support. Yeah, virtual private clouds. So I will not dig too deep into that. I will just come back to this EC. So elastic and then C. What do you think C stands for? Yeah, yep. Yeah, what else? What other C terms you learned in the course? Yes, close. Warmer, yeah.
I'm getting nervous.
Chris told you about this term.
And Jona, almost.
And Ione also. All right, let's reveal it then. The C word is container. So container services became, oh, come on. Container services became very prominent. What's container? What it relates to? Yeah.
Docker?
Yeah. Yay, Docker. They knew.
They know anyway.
Right. So Docker containers, right? They don't say Docker containers, but that's what they mean. So container registry. So you have this. You have the Elastic Container Registry and Elastic Container Services, right? And then K, Kubernetes. So here you have the cluster. So the registry is for your containers, and the containers live on some sort of cluster on Kubernetes, and the cluster is composed of EC2 instances. So you can allocate some EC2 instances for your cluster and then have containers managed by AWS for you. So this is kind of the new top level offering in terms of computations. So storage, we kind of covered a little bit. Database, that's growing as well. It was smaller last year. So they have relational database services. They have kind of a large table-like storage services. They have NoSQL storage and so on. So depending on your application demand, you can find what fits you. It's huge, right? So if I were to kind of cover all of it, it would take hours, weeks. So what's important? Well, important is the computational units, storage, database services, and then analytics. So what you can do with the data that accessible through APIs to manage your own things. So even though they offer a lot of services, it's not managed for you. It's like it's a tool for you to use and then integrate into your own solution, right? So for example, Heroku runs on top of AWS, but creates this layer which isolates you from the complexity of how it is managed, how you provision services, how you load balance, and so on. So Heroku is kind of easy to use because you don't need to think about all those things. You don't need to think, okay, how many EC2 instances do I need for this application to deal with my peak demand and to deal with my normal level demand and so on. Here you kind of need to do that yourself. Like you need to plan, you need to get the metrics from the load balancer and from some of the analytics APIs and kind of manage that. So let's quickly go through this. What are the virtual private networks or virtual private clouds? What is that? Yep.
It's like a cloud, but it's your own, but you have it on Amazon.
Yes. So virtual private cloud exactly is like a cloud service, but it's isolated from everything else, and you have your own network to manage. So you have your own IP address space, and you manage and lay out physically how it looks like. You may have European offices, US offices, and so on, but it's kind of like a cloud for you, but privately. Usually people do that for two reasons, performance and security. So on the public clouds, your instance is shared with other users. You may not know who those users are, but they have been in the past some data leakage or some vulnerabilities which may cause your data to leak to whoever is co-hosted with you. And obviously, some applications cannot allow that. There are some limitations. for the private cloud, you need to manage DHCP kind of yourself. There is no logging, so the level of monitoring is smaller for the private clouds. All right, so storage we covered. EC2 sort of. Block, what's the difference between the blocks and the buckets? We briefly mentioned. So let's talk a little bit about the cloud functions. So when you're designing your microservice or your REST API, you end up having some handlers which handle some particular requests, right? So you may have an application which registers multiple handlers for multiple resources or URIs, and then you write a logic to handle those requests, right? If you think about it, it's like a collection of different functionalities which you combine into a single web application that you deploy. So when you deployed your assignment 2, it was a single system, single monolithic system, which was handling multiple things, right? We had webhooks, we had issues, and so on, right? So now you can isolate individual functionality as if it's a single function which takes some parameters and produces some result. So for example, if I just take a registration of the webhook, I have an ability to do one thing, which is register my webhook, and then get the result, either error or that my webhook was registered, right? And I can isolate this single function into its own kind of context. And then if I do that, I can just deploy that one single unit and let cloud provider to manage that for me, right? And then I can compose my more comprehensive, more complex web application out of those single units, right? And what are the advantages? Well, I can isolate and move around kind of individual pieces of functionality. I can upgrade, for example, my webhook registration without touching everything else. In your assignment 2, if I told you we need to change how the webhooks are registered, you have to change your code, rebuild the whole application, shut the existing application down, and instantiate the new one, right? Even though we're not touching any of the other functionality at all, you have to do that because you cannot just change one isolated element. To give you more flexibility and to make the management of the provisioning kind of simpler, we can isolate that into individual aspects. Let's say with assignment 2 again, you have, let's say you have 100 users, right? Those 100 users, let's say all of them are interested in a particular callback. So all of them register a webhook, right? So you have 100 webhook registrations, okay? But all of those 100 users, they are heavy Git users. So they do commits and issue quite a lot, right? Maybe 100-fold more, right? So on 100 users, you will have 10,000 issues versus 100 requests for registration, right? When you deploy your application, you have kind of a single entry point, and the dispatcher needs to handle the incoming requests and has to say, okay, this request can be handled here, this request can be handled here, but the dispatcher is kind of a single dispatch, right? So now because we have 10,000 requests coming for issues, but only 100 coming for registering webhooks, and those ones are kind of continuous, these ones are kind of one-off events, you can isolate this. And you can have a different provisioning, different load balancer for the webhooks and different load balancer for the issues, right? But to achieve that, you need to isolate your functionality. You have to break down your monolithic application, web application, into two, right? So you're sort of trying to separate them and isolate them such that you can deploy that separately and deploy that separately. So Lambda or cloud functions are kind of the ultimate way of doing it because you're splitting it just to one function, right? So that's one thing. The second thing is you don't need to manage a server and you don't need to manage any provisioning or anything. So it's sort of a buzzword to use here is a serverless computing. So you're writing a function, you're writing a business logic, which is deployed and you don't care about anything. Like everything else is kind of handled for you, which is sort of similar to how Heroku handled that as well, right? So you could think Heroku is sort of like a platform as a service where you deploy your application and then they do all the provisioning for you. Here it's similar, but here it's done on a very small unit, just on a single function. And then you have integration. So AWS platform generates a lot of events. So for example, every time something is stored in a bucket, or every time EC2 instance comes up, or every time it goes down, or every time there is a reboot, or every time whatever, you have hundreds of different events that happen. You can instantiate like callbacks on bucket reads and writes. So for example, if you're storing images in your storage and someone is creating new image, you can get a callback, right? So you can do some filters, you can do some processing on it. So if you want to react to those events, you're effectively writing kind of a callback or function which gets triggered by those events. And it's kind of a single purpose. So, your trigger which triggers something in a database and your processor which manages something in the database has nothing to do with anything else in your application. So it's kind of isolated in its own space. So then you can kind of use Lambda for that. So if you look here and we go to those services, we see Lambda is kind of a prominent here because it becomes more and more valuable to application developers and to system integrators to use it. Again, you can kind of spend more time. Yeah, I actually have the demo here, so I don't have, let me just go. Yeah, let's go here. So if you go to the help page, I'm kind of not logged in. So you can kind of read, and you don't need to be logged in to read all the docs. You can read more about AWS Lambdas. As I said in Google lingo, they call it cloud functions. But the term Lambda is quite interchangeable. Why we call those Lambda? Where the name came from? Why Google calls it functions? Yeah.
I think it originates from the Lambda calculus.
Correct. So one of the first programming paradigms which has been invented by Clean is Lambda calculus, and it's effectively like the word lambda and the word function are kind of the same in that paradigm. So you have a number of languages that Lambda functions on AWS support. So you have Node.js, you have Python, you have Ruby, Java, Golang, and C#, and some PowerShell functionality as well. So with some of those languages, like for example Node.js, you can write the function in the editor, which is in the console itself. So then the deployment and the compilation steps and so on are done on AWS. But for compiled and Python, same. For compiled languages like Golang, you have to do the compilation. You have to do the compilation step yourself. But I will talk a little bit more about it in a minute. So yes. So what is Lambda? After my explanation, like you should think it's some sort of function which is deployed in a cloud environment, and it's triggered by some events, and then it produces some output. And this function is stateless, right? So if that function needs to read something, it needs to read it from a database, or it needs to access something from somewhere, produces the result, and then it disappears. So there is no static in this function. If you need to maintain a state, you need to save the state into a database or some persistent storage. So the function is kind of instantiated, handles the event, produces the result, and disappears, right? In theory. So what sort of event sources can we have? Well, as I said, we can have events related to the S3 buckets. We can have events related to your relational database. You can have all sorts of different monitoring events. And also you can have events which are basically coming from HTTP requests, right? So HTTP is one of the event sources that can be handled by the Lambda function. Since last year, Amazon also, so if I go here, Amazon also expanded the offering, and the triggers, so you have all those like cloud events, load balancer events. You have some Git commits, for example, which are managed by AWS, DynamoDB, S3, messaging, queuing. So Amazon offers kind of a lot of services which are useful, and you can get access to all those through the cloud function. But compared to last year, they also have some event bridges to partners. So for example, they have a partner with Sugar CRM, and you can directly get events from your Sugar CRM account. Same with Zendesk, and same with the other ones, the ones which are here, right? I don't use many of those, but for some of the, I mean, I know Sugar CRM and Zendesk. I haven't used the other ones. But this may grow as well. So I wouldn't be surprised if you will see GitLab or GitHub or even Facebook kind of integrated at some point, and then you being able to consume in your cloud functions some events from existing kind of web services. So it is kind of happening, right? So the list of event sources is kind of growing. All right, so how the workflow works. So we have 10 minutes, so I will explain it, but we will do the actual run-through demo tomorrow. So as already explained, you have to split the application into individual chunks. That's what you do anyway for testing, but here you do that on a unit which is then self-deployed. So if you think about like a microservice architectures, it's sort of the ideal situation where every tiny functionality which provides a business logic to you is isolated in its own component, compiled, deployed, and managed individually, right? So you will say, yeah, that's great, but it's a lot of coordination, and it's a lot of extra work to do for each of those functionalities, and that's true. So you have to find a balance of where cloud functions fit well and where it's like an overkill, like it doesn't provide you the benefits. So the way it works is you have to choose the design, what you will be consuming and what you will be generating. Will you be consuming some events which are kind of offered by AWS, or you will be using API Gateway? API Gateway basically provides you an endpoint, HTTP endpoint, which can be used by some sort of HTTP request. It can be post, get, delete, all the HTTP requests are possible, and you can pass parameters into the call and consume the results. The result can be of any form as well. Usually what we use JSON, but you can provide the input or output flow. It can be binary. So for example, if you want to consume some larger amount of data, you may encode it in a binary format. And then developing your function, you can monitor how it is used. So you have metrics related to how often it was called, how long does it take to process the request, and so on and so forth. You can do some provisioning. So I did some invocations yesterday. So you can see the log of all the calls. You can see some statistics, and you can configure the input triggers and what happens with the output. So you can kind of pipe it. So your cloud function can be a source of events for something else as well. So currently I have it configured that it consumes the API HTTP requests, does the processing, and then produces some kind of a logs output, and it's not consumed anywhere else. The HTTP gateway will consume the response, right? So it's a typical web API where I will call it and it produces something back. Yep.
Can you put it in your VPC?
Yes. That is a good question. I am not sure if you can deploy it on the your private cloud or whether you have to deploy it on the Amazon. Yeah, I don't know that. It looks. I didn't have a choice, but I don't have a VPC setup, right? So maybe if I had a VPC setup, then I would be able to pick where I want it. But as I was playing with it, I only had a choice of deploying it on the Amazon. Yeah. Yeah, that's a good question. I will check it out. As I said, the deployment is a little bit tedious because you have to build your application, your function yourself, and then compile it. And you need to compile it for Linux when you're using Go and upload a zip file. So you will think, yeah, it's kind of a little bit tedious to do that. It's not easy to integrate it with the kind of a nice workflow. With other languages, you can manage the code in the console here. So you have a small editor. So for some very short function code, you can kind of do that on the spot. For larger projects, yeah, you need to come up with your own way of managing that. Also, there is no versioning. So unlike some other deployment systems, for example, when you're deploying a mobile application on Google, you have a APK file, but the Google system checks the versions. And also, if you resubmit the same binary, it will say, it's the same as before, so we're not doing anything, right? Here, there are no checks and there is no versioning. So you have to manage it externally to the system itself. So the workflow is first you're deciding what you will be consuming, because that's important. You cannot write your code universally to consume different events because each event has its own format and its own structure, right? So first you're deciding, okay, what I will be consuming, what I will be integrated with, and then based on this, you have a particular format of how the parameters and how the input will be provided to your code. Then you write the code. So we will look at it tomorrow. You write your function. It's very similar to your typical API handler. That's what we did for our assignments. And then you compile it for Linux, you zip it up, and then you upload it. Once it's uploaded, it shows up as a blob, and then you can do some tests. So you can do the tests based on the generic API. I will talk about it tomorrow. Or you can do kind of a more involved tests related to the particular gateway that we use. And then you can do the test either through Postman, or you can do the internal tests within the environment itself. So we will do the actually walk through of this tomorrow. But in general, first step is deciding what I will be consuming. Second, writing the code which looks exactly like your web handler, but it has the body depending on the parameter set of what you decided to consume. Then you can produce the outputs. And then you compile your code, deploy it, you configure it. So for example, for the API gateway, I have to choose whether it's a GET request or POST request, who has access to it, is it requiring authentication or not, is it open, and so on and so forth. And then once it's deployed, it's there, right? So there are some shortcomings. So one is that once you deployed it and you don't use it, the very first time you call it, AWS needs to instantiate it. So there will be, same as with Heroku, there will be a small delay on the first call happening to the API, right? If you frequently use it, they keep it kind of hot, and then the requests are handled very fast. But the very first request after a break, after they kind of shut it down, might take a little bit of time. And then you basically charged per usage. We will talk a little bit more about it tomorrow. So conceptually, is it okay? You kind of get the concept of cloud functions? All right, any questions? So I will stop here, and tomorrow what we will do, we will kind of walk through the code and see how it's implemented, and then I will actually do a deployment step to show you like what sort of parameters you choose and how you redeploy it and how you test it. Right, so that's it. Thank you very much.